Well, the carport build is progressing. We've got about half the roof on now, and that buys me a bit of time because at least the vehicle is under cover. And this end that you can see here is Colorbond steel, so it's pre-painted steel. That's the closest match we could get to the paint that's already on the garage. It's not a perfect match, but I don't think we're going to change it. I'll just show you a couple of things inside. Now, we bought this whole structure as a kit of parts, and I guess on paper the engineering works, but in reality I think it was a lot more flimsy than I would like it to be. So one of the changes that I've made is I put in this diagonal bracing on the end two bays, and that helps to stiffen up the roof structure. And the other thing was that there was no bridging between the top two purlins except for the ridge cap. That was the only thing that kept those two purlins together. So I've added these stainless steel braces that fit between the two top purlins there, that ties them together, and that along with that diagonal bracing does help to make the structure a lot more stiff. And the other thing was that these two fascia beams were just C-purlins, and they were made of a very light gauge steel, and I was worried that walking on top of that, trying to screw the roof down, was just going to make it buckle. So I fitted a piece of 40 by 40 by 2 square hollow section steel on the other side of that C-purlin, and I screwed it to the face of the C-purlin, and that helps to make that whole piece a lot more well, stiffer, so it's not going to flex at all. So it's over 6 meters long, and this bridging material, you can see this blue stuff, is super thin. I don't know what it's supposed to achieve, but it sort of goes under compression when you tighten up that diagonal bracing, and if you go too far it just buckles and twists. But I think when the roof goes on, it's going to be a lot more rigid than what it is now. But yeah, it's coming along, and I haven't fallen off the ladder yet. Hey, g'day, it's Crusader. Thanks for stopping by. Now this is episode 3 of building the Crusader 60 model aircraft engine. Now there is a playlist and the link is up above there now. And in today's video I want to make some of the parts with the bottom end of the engine. But I also want to talk about the drawings because it was brought to my attention there was an issue with printing the drawings. So let's have a close look at the bench and the drawings. Now in today's episode I want to make the bronze bush that the crankshaft will run in. The bush will actually be an interference fit from the back of the crankcase later on. So we need to get that diameter fairly accurate. And we also want to get a good running fit between the crankshaft and the interior or the bore of that bronze bush. Now on this reduced section at this end of the crankshaft here there will be a propeller driver, and it's fixed to the crankshaft via a pin that fits into this hole here, and later on when we make the spinner, which we're going to do today, that will clamp up the propeller against that prop driver, and so you get sort of a positive drive. Now I need to talk about the drawings because somebody brought to my attention there was a bit of an issue with the way that the printing works from the PDF version of the files that I put on Dropbox. Now these are the parts we're going to make today in the drawing. So here's the bronze bush, there's the spinner, and this is the prop driver. Now I've already made this prop stud because it was a very simple part and I just made that off camera. And a viewer pointed out to me that when he printed the PDF version of these drawings that all of this dimensioning came out in a very light grey. Now I didn't notice because I just print my drawings directly from SolidWorks, which is what I use to make these 3D models and therefore the 2D drawings. But having been alerted to that issue, I went back and I reprinted all of these drawings using Microsoft Print PDF, I think is the name of the app. And in that app you can set all of the colours to black and white. So I checked the PDF version again and all of these dimensions came out nice and black and clear. So if you've already downloaded these drawings from my Dropbox link, please go back and get a fresh set, and that should fix up that issue with the dimensioning. And also go back regularly because I often edit these drawings and add things and correct things as I go along. This is the stock that I'm using for the bush. It's a bronze rod, it's just under 1 inch in diameter, and what I'm going to do is rough out the outside, and then I'm going to drill and bore to fit the crankshaft. Now I do have a 1/2 inch reamer, but it's a bit old and tends to leave a chattery finish. I think that boring is going to give me a better result. we're at 21.72, so I'm going to enter that dimension in the DRO, and then I'll machine all of this outside down to about 1 or 2 thou oversize. That's machined now to about 1 thou oversize, but I'm going to drill and bore now, because if I screw that up, there's no point in continuing with this. Really like to use a bigger boring bar to get in there, but I don't think that one's going to make it. Keep going with this one, but I can feel it sort of giving me a little bit of chatter. I did just do another spring pass. That's saying that we're slightly undersized. We'll just check with the crankshaft. Okay, that's sliding in, but not very far. Now, it could be that the bore is bell mouthed, or it could be my crankshaft. It's sort of got a very slight taper. I think what I'll do is take one more spring pass and leave it at that. I'm fairly confident I can get that fit right later with a bit of post-processing. Okay, I think I'd rather have that too tight than too loose, so I'm going to leave that there and we'll fix that later. Okay, I just put a very slight lead on that with a long angle lathe file, just to make it easier to get started when we press this in. And that should be the size. Yeah. It's always a bit hard to tell with an interference fit. I can try warming up the crankcase to see if it'll expand and just let this drop in, but if you don't get that right, you're going to press it anyway. So I'm going to leave that there. And I'm just going to finish off this outer diameter here, the bigger diameter, and deburr everything, and then we'll part it off. Okay, I'll clean up that face later on and take the sharp edges off, but that part is more or less finished now. This is the stock that I'm using to make the prop driver now. I know it looks terrible, but it's actually a piece of free machining 1214 steel. I just had it sitting on the floor of the garage for about 10 years, and that's what it looks like. But trust me, it'll be beautiful and pristine underneath. Now, in the build notes by George Genevro, he suggests that that prop driver part can be made of a free machining mild steel or an aluminium, and he suggested 2024 T3 or 7075 T6. Now, I don't have either of those, so I'm going to make it out of the steel. That means I can parkerize that later. So I'm just going to clean all the rust off, get it sort of roughed out, and I'm going to do it differently to what George Genevro suggests, but I'll talk about that later. Okay, that's all roughed out. I'm going to swap out to a high-speed steel tool. It's got a nose radius ground on it, 60 thou, and that matches up with the drawing, and that will form a radius at the bottom of that rebate. Okay, that's all of the finished turning done there now. Now I'm doing this differently because in the build notes it says that you should have the bigger diameter on the outside and the smaller diameter undercut behind it. But in my view that's a lot more difficult to do. And I think when these notes were written, things like collet chucks and collet blocks and cheap ER collets weren't as freely available as they are today. And I've got the ability to part this off, flip it round, and finish off the face of the prop driver, which also has to be knurled and counterbored. So in my view that's an easier thing to do afterwards and still maintain accuracy. So I'll get this board out now and break all the edges, part it off, and then we'll flip it around and finish it. Alright, that's really close. I think I'll leave that there. I think I'll polish inside later on with a bit of emery, but that's sort of how you want it. Alright, I'll break all the edges now and part that off. Okay, I'm going to mount this in a collet chuck now and we'll finish off this front face. So I'm just going to use this thing which I call a knife tool. It's got a very sharp edge. It's really good for doing sort of counterbores in the face of a part. So it's only got to be 0.85 of a millimeter deep, and it's just to provide relief for when we knurl the face of the prop driver. Okay, that counterbore is done now. I need to knurl the remaining section here using a straight knurl, but in reality it's not going to be a straight knurl. It has to be sort of radial grooves, and you really can't achieve that with a straight knurl. So it's going to be a little bit chewed up in some areas, but at the end of the day we just want friction between the back of the prop and the face of the prop driver. That's the knurling tool I'm using. It's fairly coarse, and I've tried it out in a bit of scrap and it sort of works. The important thing is that you clean out the knurling wheel itself, and I'm going to do that using compressed air. Now, I've seen a lot of people put oil on a knurling wheel. In my view, all that does is just traps the chips, and they just keep circulating and chewing into the surface of the part you're trying to knurl. But if you can actually remove them completely as they're formed, I think you get a better knurl. So here's my straight knurling wheel, and it's pressed up against the face of the prop driver and the collet chuck here. And I've got an indicator stand set up on the cross slide, and I've got my air blower gun directed down directly onto the knurling wheel. So that'll just clear the chips, make sure they don't get mashed back into the surface as it forms, and should get a better result. It's really hard for me to see because the camera's in the way, but just check that on the face there. It's not looking all that good, but I've raised the center of the knurling wheel. I think it was actually below center a fair way. So I'll try it again. I must say that's not as good as I would have hoped for, but it will do the job. I have already chamfered the two edges of the knurled area, which made it look a lot better, and I'll wire brush that as well, just to get rid of the little tiny burrs and points on the crests. And this comes out of the lathe now. There is one milling operation to be done on it, but I'll do the spinner first. It also needs to have a job done in the mill, and we'll do it all together. Actually doesn't look so bad like that. This little piece of stock here is for the spinner, so it has to finish at 1 inch diameter against the propeller face, 1 1/4 inch long, and this is 6061 aluminium, and I've chosen that because it anodizes really well. So what we're going to do here is to bring it to length, and I'm going to drill and tap for the propeller stud, and then we're going to finish this on the tornado radius turning attachment. I'm just using it because I have one, and it allows you to create a template to get the profile that you want. So the finished profile is more or less semi-elliptical, and I've got a template for that. But we'll get this prepped, and then we'll get it into the collet chuck so we can do the finished turning on the other end. Okay, that's drilled diameter 5.5, which is the tapping size for a 1/4 by 28 thread, and I'll cut that thread, and then the spinner blank will be mounted on the prop stud for doing the profile turning of the rest of the spinner. Okay, so we're going to grip the propeller stud in the collet chuck, and we'll push the face of the spinner stock up against the collet chuck as well, and then we can do all the finish turning on the profile of the spinner. So here's our stock for the spinner, and I've got the propeller stud in an collet chuck here, and this washer is from a thrust bearing, so I know it's flat, and that's just going to give me a space at the end of the stock so we don't run into the end of the collet chuck. I'll just screw that onto the propeller stud and just nip that up tight. So in order to cut the profile for the spinner, I'm going to use this Tornado freehand turning attachment. Now, if you don't have one of these, you could do it just completely freehand. Just get a normal turning tool and just sort of rough it out, use a file. Or you could also map out the profile on a piece of graph paper and then do a process called contour turning or step turning, where you cut at fixed increments from the end of the stock, and you can map out the depth that you need to go for each step, and that will give you sort of a staircase approximation of the shape. And then once again you can sort of smooth it out with a file and do the polishing and so on. But with the Tornado, what I can do here is make a template. I'll give you a closer look. So this is the attachment that I'm using here. Now, you can buy all of this from Eccentric Engineering here in Australia, and it's a wonderful piece of gear. I use it a lot. You can do it just completely freehand by using this tool holder and just sort of rough it out that way. But you can also make a template, and this is part of the kit that you can buy. And I have laser cut this template here, working off a DXF file from the actual drawing that I made in SolidWorks. So that section there is just a half profile for the spinner. That clamps onto a plate here, which is adjustable. Everything's adjustable. And the pointer on the end of this sort of, what would you call that? It's like a pantograph arm. It will trace along the outline of that template there. The actual turning tool just sits on this little socket head cap screw here, and as the pointer moves along the template, it just translates the shape to the point of the turning tool. And the geometry of the turning tool is exactly the same as the geometry of the follower. So as long as it can touch all the way around that template there, it will faithfully copy that shape onto our piece of stock here. Now, I've already set this up. I've set my DRO so I know where to start from. So I'll move that in. So that's where we want to be. The point of the follower is just touching the end of the template. And if I come around to here, when I get to the end of the template, we're right on the end of the stock. So what we're going to do now is just start the lathe, and we're just going to start roughing it out, getting rid of most of the stock. And as we get closer and closer, we just got to run that follower along the template all the way, and that will give us our finished shape. Okay, that finish is a bit ropey. What I forgot to do was to polish the edge of the acrylic template, because that was laser cut. The laser cutting process does leave a sort of like a sawtooth edge on the acrylic, and that's probably translating onto that part there. But the actual geometry is right, so what I'll do now is clean it up and blend it all with a long angle lathe file and some emery. Later on this is going to get anodized, and before I do that I'll polish this up again. It's probably going to be like a month before I get that done, and this will get scratched and knocked around. So I'm not going to go any further with that. What we need to do now is drill a cross hole through the spinner, which we use to tighten up the spinner onto the propeller. So we'll get set up in the milling machine, do that, and then I'll finish off the prop driver as well. This is the setup I'm using to drill the cross hole in the spinner. So I've got the biggest diameter of the spinner stock sitting on this parallel at the back, and that'll take the downward pressure from the drill bit. And I'm going to use this little wiggler here to find the center in Y, and I'll offset from the back jaw as well. And this block of wood here is to protect the point of the spinner, but it's also resilient, and when you tighten up the vice jaws, it sort of allows the point of the spinner to bury into the wood, but still provides sufficient back pressure to keep it up tight against the back jaw. Okay, that's lined up over the center of the hole. I'm going to start the hole with a 1/8 end mill because of the contour of that spinner there, and then we'll follow up with the drill bit. What happened there? Okay, I had a bit of a senior moment there. I forgot to turn the camera on when I went to drill the hole, and I did have a bit of an issue. I don't think I went deep enough with the milling cutter, and when I started with the drill bit it tried to slide down the point of the spinner. So I actually put the milling cutter back in again and went a bit deeper. Now it's left a little defect in the opening to the hole there, but I think I can blend that later on. I'll actually make a bit of a lead in on both sides with that hole there, and I'll polish it, anodize it, it'll be fine. So the last step now is to do the slot in the prop driver. Set the prop driver on this fixture plate in the vise here, and I previously set the spindle directly over the center of the bore of the prop driver, and now I've offset toward the back to the center of what will be the radius end on a slot. Now the slot is meant to be 1/8 of an inch wide, 3/16 of an inch deep. Now I actually don't own a 1/8 inch slot drill, so I'm using a 3mm carbide slot drill, and I'll just widen it out to the correct 1/8 of an inch. So I'm just going to peck away at this and get it to the correct depth, and then we'll turn it into a slot. And there will be a pin on the crankshaft that engages in this slot, and that's what drives the propeller. Okay, that should be it. Okay, I think the time has come to press the bush into the crankcase. Now I've made special installation tool number 34B that will help to guide the bush in and keep it from getting distorted. And I'm going to do this in my milling machine vise. And the reason for that is I'm going to heat the crankcase up to about 250 degrees C just to give it a chance to expand. And I can rest that on a parallel, and it's not going to topple over or go anywhere. Now I can have the bush pushed in from the back. So I'm going to go ahead and put this in the oven, and we'll let it warm up, and then we'll see how we go. Stay. I have put a little bit of oil on the bronze bush. If I had any brains, I would have turned that over so I could see when it was up tight. No, still got to go a bit further. I think it's already cooled down. All right, that's it. Okay, so it's in there now. I'll let that cool down and then we'll do a bit of an assembly and we'll wrap up what we've done today. So this end here is all of the parts we've done in today's video, and I've done the crankshaft and the crankcase previously. So to assemble this now, the crankshaft goes through the bronze bush all the way forward, and then we can fit the prop stud. And then before fitting the prop driver, we need to fit this little tiny pin which fits into that hole there in the end of the crankshaft. Now it is tiny and it's really hard to get it in there, so I'm just going to use a magnet. So it doesn't protrude very far, as you can see there, but the prop driver will fit over that now via that little pocket that's in the end. Okay, prop goes on. And the spinner. And we'll just tighten this up a little bit. And there it is. Now this is still fairly stiff, but that will free up as we go along. First couple of runs it'll free up significantly. One thing though, I was terribly disappointed to see that there's a large gap between the prop driver and the end of the crankcase. Now initially I suspected I'd made some major blunder with the dimensions and the machining, but I went and checked on the 3D model that I made in SolidWorks and it's got exactly the same gap. I also checked and did some calculations from the original drawings by George Genevro, and that gap works out to be about 1/16 of an inch or 1.58 millimeters. And I also checked with my friend in California who made one of these, Roger Taylor, and he sent me a photo and he's got exactly the same gap. Now I don't know why, it's a fairly big gap. I'm guessing that when the engine is running, the propeller will be pulling the aircraft along, and it means that the web on the crankshaft will be pulled up tight against the face of the bronze bush. So this gap here is more or less redundant. It could be improved. You could cut that gap down to a much smaller dimension, but I guess we'll stick with the dimensions that were in the original drawing. Alright, so that's where we're at today. Now in the next video I'm going to start on the cylinder, which is, according to the notes, one of the hardest parts to do, or the most complicated parts to do on the build. There will be some assembly of the cylinder. Some parts need to be silver soldered on, and there's a lot of machining. So we'll do that next time, and yeah, join me for that. Should be a heap of fun. So for today, thank you very much for watching. I'll catch up with you next time. It's Prezzo signing out. See you next time. Cheers.